Have you ever thought about the possibility of life existing somewhere beyond Earth? What if we suggested that a location within our very own solar system could harbour an ocean twice the size of any on Earth? Hidden beneath the miles-thick icy crust, this ocean reveals itself through impressive geysers, some reaching 120 miles high. And what's more, this world's atmosphere is comprised of oxygen. Sounds quite familiar, doesn't it? So buckle up and join us on a journey to the icy moon of Jupiter, Europa, a celestial body that's practically our cosmic next-door neighbour. But before jumping into any exciting insights, click the like button below to show us some love, and don't forget to subscribe for more videos like this one. Let's dive in. Europa, one of Jupiter's 7 moons, was first spotted in 1610 by the renowned astronomer Galileo Galilei. This discovery, which included 3 other moons, caused quite a stir back then, and continues to intrigue scientists worldwide. Jupiter and its moons are often likened to a mini solar system because each moon has distinct qualities. There's much to explore, from the volcanic activity on Io to the methane lakes on Ganymede. The scientific community's interest in these moons is so strong that a new JUICE mission will soon be launched towards Jupiter to examine its icy moons. The presence of water on Earth usually means life, so the JUICE mission will explore the icy surface of Europa and its siblings in search of water. But is water enough for life to exist? The exact conditions for life in the universe are still unknown, but we presume conditions similar to Earth's might lead to life. Water is a critical ingredient for life as we know it. It serves numerous functions, including nutrient delivery and waste disposal. Europa's surface has ridges and cracks that resemble those on Earth's Greenland, suggesting the presence of water beneath Europa's ice. On Earth, such formations are caused by water within and below the ice. This similarity has led scientists to believe that the same might be true for Europa. Moreover, Europa seems to have the chemical elements needed for life, further fueling the speculation about its potential to harbour life. Images captured by the Voyager spacecraft have opened a window into the intriguing structure of Europa's ice. These pictures reveal a surface rich in salt deposits and heavy metals, including magnesium, responsible for the moon's reddish hue. Similar conditions are observed here on Earth, particularly in Greenland, where volcanic activity brings salt to the ice surface. The movement patterns in Europa's ice resemble Earth's tectonic activity, hinting towards similar geological processes at play beneath the icy surface. Sunlight, our planet's primary energy source, casts only a faint glow on Europa due to the moon's considerable distance from the sun. And even so, the bright ice coating Europa reflects a significant amount of solar light back into space. Furthermore, the high radiation exposure from Jupiter with each of Europa's orbits around the gas giant likely provides a potential energy source. This radiation interaction with the ice creates oxygen, the primary component of Europa's atmosphere. Oxygen, a crucial element in Earth's organic chemistry, could fuel life between Europa's ice, even if only in the form of bacteria. The existence of life forms not reliant on oxygen, so-called anaerobic organisms, is another possibility. These life forms were prevalent on Earth in its early history, and scientists anticipate that future studies might reveal volcanic activity in Europa's crust surrounding its core. Such activity could create hydrothermal vents similar to those in Earth's deep sea regions. These vents harbour a surprisingly high density of life forms, including fantastic creatures and corals. If Europa's rotation around Jupiter triggers similar processes at the bottom of its ocean, these hydrothermal zones could become potential hotspots for life. In conclusion, Europa seems to possess all the necessary ingredients for life. Post the discovery of Europa and its sister moons Io, Ganymede, and Callisto, Approximately 4 centuries elapsed before the distinctiveness of these Galilean satellites was truly unearthed. During the 1960s, ground observations unveiled that Europa's surface was largely frozen water, akin to most other celestial bodies in the outer solar system. Initially, Europa was deemed just another ordinary ice moon. However, subsequent investigations revealed an extraordinarily high reflectivity of the moon's surface, and this suggested the ice was incredibly pure and relatively recent, a rather unusual finding. To understand this better, scientists needed a closer examination, and they finally got their chance through the Voyager probes. The probes captured detailed images of Jupiter's moons, drastically changing our perception of Europa. Voyager's images depicted a surface brighter than Earth's moon, adorned with various bands and ridges and notably devoid of large impact craters or tall cliffs and mountains. In other words, Europa's surface was surprisingly smooth compared to other icy moons. This anomaly sparked intrigue. Every celestial body in the solar system is subjected to meteorite bombardment, but traces of these impacts on Europa were either extremely faint or missing altogether. Moreover, dark stripes across Europa's surface seemed to fit together like puzzle pieces, with dark, icy material seemingly flowing into the cracks. This led scientists to speculate that Europa's surface was dynamically active. The absence of large impact craters suggested that Europa's surface was relatively young, and any impact traces might have been erased due to ice streams escaping from beneath the crust or the sinking of ice under its own weight. However, a puzzle piece was missing, as the visible cracks on Europa's surface did not align with the expected patterns that would form due to gravitational tides as the moon orbits Jupiter. This led to a hypothesis that Europa's ice crust might not be solid, but separated from its interior by a layer of liquid or slightly warmer ice. This hypothesis sparked interest in Europa, and the Galileo probe, launched in 1989, provided the opportunity to study it more closely. With data from a dozen close flybys near the icy moon, one key observation was that Jupiter's magnetic field collapses in Europa's vicinity, suggesting the presence of a conductive material, like a saline ocean underneath the icy surface. Scientific evidence strongly suggests the existence of a subsurface saline ocean on Europa, a conclusion drawn from the observed magnetic disturbances around the moon. These disruptions, typically caused by the presence of a vast body of water, were most likely due to a saltwater ocean lying beneath its icy surface. The intrigue around Europa deepened further with the discovery of a unique snow type on Antarctica's ice shelf, which is believed to be also present on Europa. This unusual snow appears to fall upwards, as it is less dense than saltwater on Earth and Europa. Due to the thickness of the ice on Europa, this snow could ascend from below the crust, potentially forming inverted mountains similar to those on Earth. Activity beneath Europa's ice is also indicated by geysers that periodically erupt from its crust. These ice geysers have been recorded thrice over the past decade, reaching heights of up to 125 miles. Scientists attribute these geysers to the friction and temperature increase between the subglacial ocean and the ice lid as Europa orbits Jupiter, leading to ice cracking and subsequent eruptions of warmer ice or water. Furthermore, oxygen from Europa's atmosphere gets introduced beneath the ice crust due to these cracks, which increases the possibility of life on Europa. We anticipate further exploration and studies of Europa in the coming years. NASA's upcoming mission, Europa Clipper, set for launch in 2024, aims to determine if Europa possesses conditions suitable for life. And this mission will deploy 9 scientific instruments, including high-resolution cameras, spectrometers, a radar, a magnetometer, and thermal equipment. These tools will comprehensively understand Europa's surface, underground lakes, magnetic field, and chemical composition without drilling through the ice. Once the probe reaches Europa in 2030, scientists anticipate it will provide insights beyond mere composition and structure. They also hope to detect new ice geysers and collect samples after discovering a water plume over Europa's south pole in 2012. The mission's primary objective is to determine, through the anticipated 45 to 50 flybys, whether there are potential habitats for life beneath Europa's icy crust. Enhanced imagery of the Moon will assist scientists in pinpointing the areas of highest interest for further exploration. The plan is to approach as close as 25 miles to the surface, a significant improvement on Galileo's closest distance of 160 miles from Europa. However, Jupiter's intense radiation field hinders the possibility of getting closer, which prevents prolonged proximity. Another hurdle in this research is energy limitation. The probe will be equipped with solar panels, but its performance and capabilities may be hampered due to its distance from the Sun. Nevertheless, a comprehensive study of Europa will still be feasible with these planned trips. The prospect of exploring Europa's icy depths is already on the horizon, even as preparations for the Clipper mission are in full swing. Scientists are drawing plans for another groundbreaking project to succeed the Clipper mission, one that will turn the pages of space exploration. They aim to touch down a state-of-the-art robotic probe on Europa's enigmatic surface. In conclusion, exploring Europa is a journey into the unknown, a testament to our insatiable curiosity and the relentless pursuit of knowledge. From the extraordinarily high reflectivity of its icy surface to the tantalizing possibility of an under-ice ocean, Europa continues to surprise and intrigue us. As we await the launch of the Europa Clipper and the subsequent missions, it's clear we're just beginning to scratch the surface of what Europa might reveal. So let's remain patient and let science take its course. Let's look forward to the new discoveries that the future holds for us. Stay tuned to our updates and don't miss out on this extraordinary journey through our solar system. Join us in this quest for knowledge by subscribing to our channel and sharing this content with fellow enthusiasts.